Okay, this is section 7.5, parallel lines and proportional parts in geometry. It's on page 534. Okay, I've taken the liberty of writing some things down here so that we can kind of just go with the flow here. We are on page 534. It says, when a triangle contains a line that is parallel to one of its sides, the triangles formed are similar by the AA similarity postulate. So what I'm saying is, if we have a triangle, okay, we have a triangle and we draw a line, and this line can be anywhere in here, but it's parallel to a third side, okay? What we're saying is this little triangle here, ABE, okay, ABE, I'm sorry, it's a mistake, is ABE is similar to the triangle ACD, okay? And the reason that is because this angle is congruent to itself by the reflexive property, and then this angle and this angle are corresponding, so they're congruent, and this angle and this angle. So you only need one pair, but the angles are congruent by corresponding, so the two triangles are similar. Okay? Now, because the two triangles are similar, okay, we can actually say we have what we call the triangle proportionality theorem. And it says if a line is parallel to the side of a triangle and it intersects the other two sides, which we have, then it divides the sides into segments of proportional length. So what we're saying is that this length over this length is congruent to this length over this length. And I have a picture or saying this. So if BE is parallel to CD, then AB, this length here, over this little tiny length here, is equal to this length here over this little tiny length. So AB over BC equals AE over AD. So we're going to have some examples here. I got a couple here. I may change marker color here. According to this theorem then, according to this theorem, how can I solve for x in the first one? This is P, S, R, Q, and T. This is 2.5 from here to here. This is x from here to here. From here to here is 7.5, and from here to here is 3. How could I solve for x?
Did you do x plus? Do that 2.5.
Actually, use this triangle proportionality theorem. So x over this piece here over the little piece, 2.5, is equal to, now finish it.
7.5 over 3.
Okay. So if I cross multiply, I have 3x equals, what's 7.5 times 2.5?
I got 10.
7.5, you added them, didn't you? I want you to multiply them. 18.75, and then would you take both sides divided by 3? We get x equals what?
6.25.
6.25. Do you agree with that? All right. Okay. So on this particular one, we know that this side is congruent to this side. And so we can actually find y. How can we find y quickly here? How can we find y quickly here? This distance here is congruent to this distance here. So we can just say that 3y equals 1/2 y plus 20. So we can actually solve for y there. Alright? So if we subtract 1/2 y from both sides, right? We get 2.5, which is 5/2, right? 5/2 y equals 20. And I'm going to multiply by the reciprocal on both sides. Correct? So I get 5/2 y times 2/5 equals 20 over 1 times 2/5. That leaves y equals 8. Is that true? That means this equals what? From here to here is what? If y equals 8, how far is it from here to here? Here to here.
8.
Times
Oh,
24.
24.
So that means this has to be 24 also, right? We can check it. Half of 8 is 4. 4 plus 20 is 24. Correct? Now we can go back to the triangle proportionality theorem, and we can say what? That this piece here, 24, over 24 equals 20 minus 3x over 2x minus 5. Now, the question I have for you is, since these are both 24, can I just set these two equal to each other? Because you're multiplying by the same thing. Yes. Which proves that if these are parallel and these are equal, then these have to be equal also, right? So now we can say 20 minus 3x equals 2x minus 5. Does everybody get that?
Yeah. Why would you not be writing it?
Oh,
What's-
okay, never mind. Sorry,
Okay.
I was looking at the wrong thing.
Okay. So I can do plus a negative here and plus a negative here. I'm going to subtract 2x from both sides, correct? And I get 20 plus, now if you don't understand this, stop me. Negative
I have a
5x
question.
equals a negative 5. Yes?
Where'd
What's-
you get the 2y from? Or what is that? Or
This
the
is 24 and 24,
Okay.
yeah. And since they're equal, then these have to be equal, right?
Yeah.
Okay. So if I subtract 20 from both sides, I'm running out of room here, but I get a negative 5x equals a negative 25. So x equals 5. So if I want to solve for x and y, I get y equals 8 and x equals 5. And I can plug them back in and find these also.
On the other one,
Yep.
does it say x equals 6.25?
Yes.
And then on like that, if line segment DE is parallel with line segment CD,
Yes.
does that say E, D, or AD
This right here,
on the next one?
AE over AD. So this right here, this piece here, is to this piece as this piece is to this piece. Okay? Now, I want to point out that the converse of the proportionality theorem is also true. Okay? That means that if you have the sides in proportion, then this line must be parallel to this line. That's all that means. So the converse of the triangle proportionality theorem is also true. Okay, are we ready for the next slide?
No.
Okay. We good?
No. Not yet. Also,
Also true, sorry, I kind of ran that red in there. The converse of the triangle proportionality theorem is also true. Okay,
I'm ready.
got it? All right. All right, slide 2. Slide 2. Okay. Says, I'm not going to put the piece of paper on it. We'll just go through it. It says, we got to define mid-segment. Mid-segment. The mid-segment of a triangle is a segment with endpoints that are midpoints of two sides of a triangle. Okay? So if I have a triangle here, okay, the mid-segment is the midpoint of this side and the midpoint of this side. Wow. If I connect those, that's called a mid-segment. Okay? It's called a mid-segment. Didn't leave myself a whole lot of room. Okay? So I'll say that again. If I have the midpoint of this side and the midpoint of this side and I connect them, that's called a mid-segment. Every triangle has 3 of them. Because you can connect any two sides of the midpoints of any two sides. Okay? Now, we have what we call the mid-segment theorem, which says that if I have a mid-segment of a triangle, so if I have one of these guys, it is parallel to the third side and is half the length of the third side. All right, so let's say that I draw a mid-segment here. I know it's a mid-segment because this is marked congruent and this is marked congruent. This is marked congruent and this is marked congruent. Notice that this length is not the same as this length, or it doesn't have to be. It can be, but it doesn't have to be. But it is the same as this, and then these two are equal. So this means that this is the midpoint, and this means this is the midpoint. If this is true, then JK, this length right here, is parallel to the third side. They're parallel, and JK equals half of FG. That means if FG was 20, how big would JK be? 10. Okay?
Does that say 1/3 or 1/2?
1/2. 1/2. 1/2. Okay? All right, so let's take a look at this picture down here. Okay, this is A. Oh, this side is not defined. This side is not numbered. Sorry. What letter is that? I believe this is C. Yep. Okay. So this is AC from here to here. Notice that this is the midpoint because this is congruent to this. E is the midpoint of CB because this is congruent to this. D is the midpoint of AB because this is congruent to that. So basically, we could draw all 3 mid-segments if we wanted to. We have 2 of them drawn. Okay? This length of AC is 15. This angle right here is 82 degrees, and this length of FE is 9.2. Okay? So, the first question is, how big is DE? DE is this right here. DE is the mid-segment, so it is parallel to this side. It is also equal to half of that side's length. So how big is DE?
7.5.
it would be 7.5. Now, dB is interesting. dB is from here to here. It's equal to from here to here.
9.2.
That is correct. You want to explain that?
I mean, it's like the line that like cuts. I don't know. Like,
Okay, see this?
yeah.
This is the mid segment. This is the mid segment of AB, right? That means it's half of this. So the whole thing is twice this, right? So this little piece will be half of twice this, which is actually just 9.2, right? Okay, now the tough one. FED, right here. FED. How big is FED?
9.8.
Nope. Anybody else want to guess?
I'm just gonna say 82.
82 degrees, because this angle and that angle are alternate interior angles, because this line is parallel to this line, which makes them alternate interior angles of parallel lines are congruent. Questions about that? Okay. We good? Oh,
No, it's not right here.
okay. Can I move it? All right. Page 3. Okay, so a corollary is, if you remember from first 9 weeks, a corollary is a postulate that happens because it goes off a theorem. Okay? And we have a couple of corollaries here. The first one is proportional parts of parallel lines. It says if 3 or more lines intersect 2 transversals, then they cut off the transversals proportionally. Now, okay, so here's my 3 lines. And the distance between the lines are not the same. They don't have to be. They could be, but they don't have to be. This point is A, this point is B, and this point is C. This point is E, F, and G. Okay? And the 3 lines are parallel, which is marked parallel. This corollary says that the length of AB, this length right here, to BC, is equal to EF to FG. So let's say that I had, this is 3, and this is 6. Okay, and this is 2. How big is this? Well, this says that 3 over 6 equals 2 over what? And that's the what? So this is a half, so this, what do we guess an x is without doing the cross product? It would be what, 4, right? And that's how we get them in proportionality. Questions on that? Okie dokie.
Is that an E?
This one? EF over FG. Oh, this one right here is an E. Yep, that's an E. Sorry, that E's and F's are really hard to do with those markers. Okay. So the next corollary, once again, a corollary is a postulate that comes directly from a theorem. It says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on each transversal. Okay, so here's our two transversals, and we have parallel lines, and this distance from here to here is equal to this distance from here to here. If we have parallel lines, in this case we have 3, that are cut off by two transversals so that one transversal is cut equally, then any other transversal has to be cut equally also. That means that this distance here is the same as this distance here. I'm not saying that this distance here is the same as this here. What I'm saying is this distance here is the same as this distance here. Okay? So you can't, if this is 7, then this is 7, but this over here might be 9. And we're not saying that this distance is the same as this. We're just saying that it cuts it off equally throughout the transversal. Any questions about any of this? Yes, Tyler.
Would that mean that AB is also congruent to BC?
Yes. That would mean that if AB is congruent to BC, then these two have to be congruent also.
Okay.
Okay? All right. Did we get that? Melcha? We good?
Yeah.
All right. And our final slide of the day. Yay, right? Okay, we're going to put this into practice. Here we have a transversal. Whoops, I forgot to draw the other line here. I'm going to draw the other line right here. Okay, so this piece from here to here is 12 minus 3y, and this piece is 16 minus 5y, right? And this piece right here is 1/4 x plus 6, and this piece here is 2x minus 21. I wish I would have put them over here. I guess I could and erase. Would that be better if I put them over here? Would you understand it better? Okay. Erase them. Okay, so this is going to use that last corollary that we talked about. It said if this cuts off equal parts, then this cuts off equal parts, correct? So to find x and y then, to find x, to find y, I know these two are equal, correct?
Mm-hmm.
So I go down here and I set them equal. Change them to addition. I subtract a negative 5y from both sides, which is the same as plus a positive. So on this side I get 12 plus 2y equals 16. Now I subtract 12 from both sides, right here and here. And I get 2y equals 4, y equals 2. So now, since these two are equal, that corollary says if these two are equal and these are parallel, remember these are parallel, I didn't say that, but these are parallel, then this must be equal to this. These have to be parallel, these have to be parallel and for that to occur. So I can set these two equal. So I've done that right here. I subtract 2x from both sides, right here and here. That is a negative 1 3/4 x plus 6 equals a negative 29 because this is 0. I change this to an improper fraction in negative 7/4 over x plus 6 equals a negative 29. Then I subtract this 6 from both sides. This is plus a negative, so I have a negative 7/4 x equals a negative 35. And then I multiply by the reciprocal of a negative 7/4, which is negative 4/7 on both sides. The 35 cancels with the 7, the negative 35 cancels with the 7, so I get a negative 5, and a negative 5 times negative 4 is 20, so x is 20. I could find those links by substituting in also, if you needed to. Okay, so our assignment is page 539, numbers 10 through 26, 15 through 38. And it is due Friday, but I'm going to lecture on Thursday. Can you read that? It's 10 through 26, 15 through 38.
Can we write that?
Yeah, if you'll put it on the board, that'll be great. Okay?